Hey everybody, welcome back. It's the machine learning lecture, the one everybody's been really excited for. All right, we're going to cover quite a lot of ground at kind of a high level, giving you a bird's eye view of what machine learning is. And we're going to do more next lecture as well. So this is going to be a two-parter. So before we get into the details, let's just take a look at the course and the reminders. So by now you should already have turned in your quiz for Reading 4. So since I'm giving you this lecture a little bit late, it's past the time in which R4 was due. Assignment 2 is already in Canvas waiting for you, and it is due next Friday at 11:59 p.m. So please take a look at that. It shouldn't take you a terribly long time, but please get into it beforehand, because if you have some questions, if it doesn't quite make sense, then you will want to make sure you get a chance to ask those questions on Piazza or from the TAs, etc. Now, this is actually, you're going to be doing some data work doing this. We're going to put it for you in a form that you can easily do it. It doesn't require any programming, but you are going to be manipulating some data. So hopefully you're excited to do that. Now, I just want to note that even though we are relatively far away still, several weeks from the project being due, you should be working on it continually in your groups. You're going to be working as a group. You need to keep organized and keep working towards your final goal. So to help you out, we're going to try to get the grading done for the project proposal just as soon as possible. I'm hoping it will hit you on Monday. So that's the goal, at least. We'll want you to, of course, incorporate any feedback we give you from the project proposal. So to me, the grades are not really important on A1. I'm sure that you care. You want to have good marks. I get that. But I'm asking that the TAs spend much more of their time giving you a critique of what makes your project better, right? And they're going to put a lot more effort into that than giving you a few points here or a few points there. All right? And then finally, of course, just remember that part of the project that is available to you is for extra credit. You can actually do some implementation, right? If your group is interested in actually scraping data or manipulating data or doing any part of it, then that can lead you to extra credit. Now, so I think it's important that if this is of interest to you, that you discuss that now, because this will be some of the most time suck sort of thing to actually implement. All right? So that's about all I had to say on that matter. Let's get into machine learning. So today we want you to be able to figure out what do we use machine learning for and what are the right approaches for a given data set. So just to bring us back to our big overview of analyses, right? On this one branch here, we have, if you're going past, hey, I wanted the highlighter. Right, if you're going past the exploratory stage and you're not going into the causal end of things, the next thing in our branching paths is to try to predict measurements for individuals, right? If you're trying to do groups, then you go into inferential statistics, right? But if you want to, for each individual, produce a prediction, now we're in to something that is machine learning is an ideal tool for, okay? So in predictive modeling, we can easily apply machine learning techniques, create some sort of model that will be able to make a prediction on future data. All right, so we're going to use machine learning to predict, right? That's the single most common use of machine learning for a data scientist. We have we have a bunch of elections taking place. We want to gather previous election data, and we want to predict election outcomes, right? We have a bunch of data about, pandemic things happening, and we're going to feed it into our machine learning algorithm, and we want to predict just how bad coronavirus situation is going to be in a given location 2 weeks from now. Okay? And we're fitting these. The important part is that, again, we're predicting not just uh, the fact that we're predicting, but that we're also predicting for individuals, for individual counties. We want to predict their coronavirus or election outcomes, right? We want to predict it on a location by location basis. And we may be using some sort of patterns in data from hundreds or thousands of locations. We're going to learn those patterns in the data, and then we're going to apply the machine learning model to get at the prediction for this one place. All right? Okay, so we now know what we're going to use machine learning for, but what is it, right? Well, so Manuela Veloso is head of machine learning at a major school well known for machine learning. And so let's see what she has to say. So there's a couple of things I want to highlight here. Okay? The fact that it's part of artificial intelligence. Okay? The fact that what we're looking at is how agents can improve their blah, blah, blah. Okay? So machine learning is about machines improving, right? And it's a field of artificial intelligence. The rest of this is kind of like her own particular take, but I think that those are things that most people would agree on. Let's find another one. So Andrew Ng is, maybe one of the most famous people in machine learning at the moment. So besides having been chief of basically everything, he founded Coursera, which has got an awful lot of machine learning content on it. So we get right here, getting computers to act without being explicitly programmed. So that's an implied learning, right? That's an implied, it adapts for itself. So SAS is basically the biggest company in statistics and analytics. So their take on the situation sounds suspiciously like it's just analytics, right? It's a method of data analysis. Okay. And it automates. So once again, we have that, it's automatic. It does it itself. It takes the data and creates the model without too much human intervention. Well, I think the final authority that we should ask about machine learning is one of the biggest products of machine learning that we know about. So if you just let Google's autocomplete have a go at it, we will find out that machine learning is just regression. It's just statistics. It's just a bunch of if statements. These things are all true, right? Machine learning looks an awful lot like the inferential statistical technique we were using a little while ago called regression. There's a lot of similarities between them, and regression is the first thing I teach when I teach machine learning to people, just because it's a simple and easy to kind of grasp thing, which works exactly like more complicated machine learning algorithms. So, and machine learning is just a kind of statistics. It is, in the end, all about adapting things, right? And it's also, related to artificial intelligence. It's memes, baby, memes. So really, it's all building on each other. Where analysis and statistical modeling and machine learning and artificial intelligence actually are separate from each other can be hard to determine. So it's all a continuum, all shades of gray. Well, what can we distinguish? All right. So You've heard the buzzwords: artificial intelligence, machine learning, deep learning. What are the differences between them? Well, since, as I was saying, it's hard to distinguish, they blend together at the edges. But this is my take on the situation. Okay, this is my slide. So, artificial intelligence is historically the oldest of the fields. Okay, it starts off in the late 50s, early 60s, and it goes reasonably strongly all the way into the 90s. Now, at a certain point in the 90s, the the term artificial intelligence became much less used. It became kind of replaced, in fact, by machine learning, as I'll show you in a second. Um, but it's made a comeback now in the last decade because people have started using artificial intelligence a lot more as deep learning took off like crazy. And deep learning, people, is taken off to the point where people who have no idea what deep learning is talk about deep learning, right? And when people who have no idea what something is talk about it, they oftentimes confuse it. And artificial intelligence was a word that was around, people grabbed onto, and all these managers at, Procter and Gamble ran around trying to find artificial intelligence experts because they knew they needed that when what they were really talking about was deep learning, right? So that's the history of the use of the term, but what does the term actually mean? So artificial intelligence, I'm going to define it effectively as computers solve tasks that make them look intelligent to a human, okay? So the most famous thing in artificial intelligence maybe is the Turing test. The Turing test says, let's get a computer that is quote unquote intelligent to pretend it's a human being and have a person converse with both human beings and this computer. And if the real person who's chatting with both some humans and some computers can't tell the difference between the groups as it's chatting, then the computers pass this Turing test. The computers are, for all intents and purposes, intelligent because they fooled a human being who is intelligent into not realizing the difference. Okay? So that's my effective definition. Computers look intelligent to humans. There's a problem in this definition, which is look intelligent is not the same thing as be intelligent. And what exactly is intelligent anyway? Okay? So we can commonly see that some things that are very, very simple, that are following simple rules, look intelligent to people, right? Swarms of birds, like when you have just like hundreds and hundreds of birds and they're all flying in this fixed pattern. So you can replicate that in a computer program with exceptionally simple rules that you can write down on a 3x5 note card. Okay? So there's not much intelligent there, but it looks to people like there's a lot of intelligence when you watch a flock of birds doing that. So that's just my FYI. So mechanistically, what is AI? Oftentimes, originally, it was a logic-based system, a mathematical logic system. But again, as the term becomes an umbrella for everything, it absorbs everything, including artificial neural networks, machine learning, reinforcement learning, deep learning, blah, blah, blah. Okay, so here's my Venn diagram, right? So machine learning is a subset of artificial intelligence. I'm following on from what Manuela said, okay? So computers, the effective definition of what machine learning is that computers improve through experience, okay? That is not the case with artificial intelligence. Artificial intelligence, they just have to look intelligent. They could be programmed by you to do that, right? That's a bunch of if statements. A computer programmer comes in and writes some if statements and it looks intelligent, right? Okay, but the machine learning system is typically going to be taking the data in and using the data to create its improved performance. Okay, mechanistically, machine learning algorithms are often statistical in some fashion. Either they represent things as statistics, explicitly. That's the kind of learning they're doing. Or maybe just the theory that created the algorithm is based upon a statistical learning theory or something like that. Okay, and in the end, all these functions work, all these algorithms work by optimizing a function. They're trying to take some function that we can define, which says you can do better as a machine learning algorithm by minimizing this function, by making this function as low as possible. And it's the design of that objective function, of that loss function, as we call it, it's the design of that function which shows you what a given algorithm is going to learn. Whoops, went the wrong way. All right, lastly, deep learning. Deep learning is the only one of these that has exactly the same definition for its effective nature and its mechanistic definition, okay? So deep learning is a multi-layer artificial neural network that improves at tasks through experience. And like the rest of ML, it works by optimizing a function. Okay? So deep learning is a kind of machine learning. This is the Venn diagram, right? But historically, while it starts way back in the 60s with the first artificial neural networks, what we call deep learning is really an outgrowth of stuff that started in the early 2000s, but took off in the late 2000s. All right, so that's my big overview. Machine learning. What does it do when you actually do the do? Well, you take some data, you choose a model to put it through, and the data trains the model. At the end, this model is trained, and now we can take new data that's coming, new elections, right, and predict what's going to happen. So you use the data you have now to make a prediction later on new data. Okay, and as we said, we're using this for predictive analysis. So let's show you a data science-y version of this. Okay. So our problem is that these credit card companies process umpteen gazillion credit card charges every day. And that's a huge amount of data. So can we use the data that's there already in the system, like the time of the charge, the location, the price, okay, to predict whether that charge is fraudulent or not? And maybe more to the point, to actually do this well, we're going to check all that versus who the person is, right? So you could guess that if the person lives in Utah, if they suddenly make a charge in Japan, that might be fraud, right? So this is the kind of predictive analysis that we would do with a machine learning algorithm. All right, quick quiz time. So we've said that it's a predictive analysis system, right? So which ones of these questions is most appropriate for machine learning? I'll let you click through to the Google form, and just a little FYI, I've decided to try to break these up into shorter bits again, these lectures, so that it's easier for people to digest. So I'm going to take a little break while you go fill out this quiz. All right? I'll see you on the flip side.